Hey everyone, Math 103, we're working on section 5.3 today. We're going to be factoring a little different type of trinomial. In the trinomials we've seen before, the x squared has been by itself. In other words, it's had a coefficient of just 1. Now we're going to look at trinomials that have coefficients that are not 1. And one way to do these is with the trial and error method, where we look at how many different ways can we write 10x squared, how many different ways can we write 3? And we're just going to fill in some binomials here and then FOIL them and see what we get. So there's two different ways we can write 10x squared as a product. It's either going to be 1 times 10 or 2 times 5. So we could have 10x over here and x over here. I'm going to make two different versions of them. And we could also have 2 and 5. So 2x times 5x. And when we FOIL, we do first times first, and that gives us the x squared term. So there's all the different ways we can write 10x squared as a product. Now let's look at 3. 3 is a prime number, so it can only be 3 and 1. So we could have plus 3 over here and plus 1, or we could reverse them. Plus 1, plus 3. And now we can do the same thing with the 2's and 5's. We could have plus 3, plus 1, plus 1, plus 3. So there's all different ways we can write two binomials, and we multiply them together. We get the first term here, 10x squared, and we get the last term here, 3. Now what we can do is FOIL and see if it matches that middle term, and then we'll have found our factorization. So starting here, just looking at the middle term, I'll have 10x times 1, which is 10x, 3 times x, which is 3x, add them together and we get 13x. Does not match the middle term, so this one cannot be it. All right, let's try it here. 10 times 3 is 30, 1 times x is 1, we get 31x, doesn't match, so that one can't be it. Next one. We got 3 times 5, that's 15, 2 times 1 is 12, add them together and we get 17. So that one has to be it. And when we FOIL this, we get 2x times 5x, that's 10x squared, plus 2x, plus 15x, and plus 3. Combine like terms, we get 10x squared, plus 17x, plus 3. And that's where we started. So that is the factorization. All right, try out this trial and error technique on your turn number 1. 6x squared plus 13x plus 6. So there's two different ways we can get a 6. 6 times 1 or 3 times 2. And same thing for the other 6. And we'll try some different combinations in there. And there are a few more you can try. And now let's start foiling. So we get 36x here. Well, that's not going to match 13x. So let's go on to the next one. Here we get 18x, 2x, that's 20, so that doesn't match. Here we got 9 and 4, that's 13. So there is our factorization. All right, let's FOIL just to make sure. 3x times 2x is 6x squared. 3x times 3, that is 9x. 2 times 2x, that is 4x. And 2 times 3 is 6. Combining like terms, we get 6x squared plus 13x plus 6, and that matches. So that is our factorization. All right, now for the warm-up, we're going to do a slightly different version of what we did last time. Last time, we found two numbers that multiplied to get 8 and added to get 14. All right, multiply to get C, add to get B. Now we're going to do a slightly different version. We want two numbers that multiply to get the product A times C. So multiply A times C together, you get 24. And then we'll look at factors that add to get 14. So go ahead and work on the warm-up. All right, first one, our factors are 24. We can have 1 and 24. We can have 2 and 12. Looks like 2 and 12 add together to get 14, so there's our two numbers, 2 and 12. Second one, we got 2 times negative 6 is AC. So that's negative 12. And we want two numbers that multiply to get negative 12 and add to get 11. So it'll be 12 and negative 1. All right, now we're going to go ahead and factor a trinomial with a not equal to 1. And we're going to use this AC method. And we're going to look at two different methods for solving these. Fortunately, they both start the exact same way. We're going to take our values of A B, and C. Now we'll do just as we did in the warm-up. Find AC. Well, as it turns out, this is warm-up number 2. So we already did that. And we found that we got 12 and negative 1. So there's two numbers that multiply to get the product AC and add to get B, 11. Now we're going to take these two, and the first method I'm going to show you is the more algebraic method. So what we're going to do is we're going to rewrite this initial trinomial here. 2x squared. Now we're going to split this middle term up into two terms using our two numbers. So I'm going to split that up into plus 12x minus x. And then the constant comes down. So nothing has changed here in this polynomial in terms of its value. All right, we still have 2x squareds. We still have 11x's. We just wrote them as plus 12 minus 1. And then we got a negative 6 on the end. So we went from a 3-term polynomial to a 4-term polynomial. And we've seen a technique in the past about how to factor 4-term polynomials. And that is factoring by grouping. So what we're doing today is we're combining the technique for factoring an A equals 1 trinomial with factoring by grouping to do A does not equal 1 trinomials. All right, now we've got it split up into 4 terms. Now we're going to factor by grouping, doing the first two separately from the last two. We're going to factor these two. We can factor out a 2x here and get x plus 6. And here we've got the same terms as inside the parentheses, but with different signs. So we're just going to factor out a negative 1. And that gives us x plus 6 inside the parentheses. All right, last step in factoring by grouping, x plus 6 times 2x minus 1. All right, let's practice using this method. On your turn number 2. And this is originally designed to be a partner's activity, but we can do it on our own. I recommend practicing both techniques on all of these. But first one, let's do this algebraic technique. We're going to factor 6x squared plus 17x plus 12. All right, so start by identifying A, B, and C. Got A is 6, B is 17, C is 12. I'll find A times C, and that is 6 times 12, or 72. All right, now we want two numbers that multiply. Do 72 and add to get 17. So we're going to list the factors of 72. All right, there's all the factors of 72. The pair that add to get 17 are 8 and 9. So we're going to use these two numbers to split up that middle term. And it does not matter which order we write them in. It'll work either way. All right, now we'll factor by grouping. So I'm going to factor these first two. Factor out a 2x to get 3x plus 4. And here I'm going to factor out a 3 to get 3x plus 4. And we get 3x plus 4 times 2x plus 3. All right, so there's the algebraic technique. Now I'm going to show you more of a visual technique for doing this. So I'm going to go back to our original problem here, original example, which was 2x squared plus 11x minus 6. And we're going to create a box. And this is where the terms are going to go. Now always, the squared term goes in the upper left, 2x squared. And the constant always goes in the lower right. And now when we solved this before, we found AC was negative 12, and our two numbers were 12 and negative 1. And we split up that middle term using those two numbers. We're going to do the same thing this time, except these are going to go in these two boxes. So I'm going to put 12x over here and negative x over here. All right, now we need a box to put the answers in. So I'm going to put the answer boxes up here. Now what we need to do now to complete this is to factor in 4 different directions. We're going to take out the greatest common factor in this direction, and this direction, and this direction. And when we do this, we're going to, oops, didn't mean to put a negative in there. Oh yeah, I did. What we're not going to do is worry about the negatives. When we factor, just pretend that they're all positive, then we'll deal with the negatives later. Okay, so in this direction, there's no x to factor out here, so we can only factor out numbers. Greatest common factor of 6 and 12 is 6, so 6 goes up here. And here, we can factor out an x. In this direction, we can factor out 2x. And in this direction, greatest common factor is just 1. And now we need to take care of the negatives. So the deal is, if this box that we initially put terms in is positive, then the box next to it stays positive. So this one's positive, that means this one's positive. This one's positive, meaning this one and this one are positive. But this one's negative, so we take that negative and put it on this one. And there's our answer, x plus 6 and 2x minus 1, which is the same answer we got last time. Right, this technique can take a little getting used to, about how you set up the box and everything, but it is a fairly straightforward technique once you learn how to set it up. So let's practice this. Your turn number 3. Let's do the box method on this one. Well, this one ends up being pretty similar to this one. We just switched the 6 and the 12. So AC is still 72. Still have 17 in the middle, so our two numbers are still going to be 8 and 9. So now we can set up the box. So 12x squared goes in the upper left. Constant goes in the lower right, positive 6. And now we've got our two numbers to make the x terms, 8x over here and 9x over here. Now we'll factor in 4 directions to get our answer. So in this way, greatest common factor of 8 and 6 is 2. And this way, greatest common factor of 9 and 12 is 3, and we got an x in there as well, so 3x. These will always be x terms, these will always be constant terms. Okay, this way, greatest common factor is 4x, and this way, greatest common factor is 3. So our two binomials then are 4x plus 3 times 3x plus 2. Your turn number 4, we're going to go back to factoring by grouping on this one. 15x squared minus 14x plus 3. So there's our A, B, and C values, 15, negative 14, and 3. So we'll find AC. It's 45. Then we need two numbers that multiply to get 45, add to get negative 14. So those are going to be negative numbers. Negative 1, negative 45, negative 3, negative 15, negative 5, negative 9. And the two that add to get negative 14 are negative 5 and negative 9. So we're going to split up that middle term using these two numbers. And now we can factor by grouping. So here we can factor out a 5x from the first two terms. We get 3x minus 1. And then over here we can factor out a negative 3 and get 3x minus 1. So our factorable form is 3x minus 1 times 5x minus 3. All right, your turn number 5. Let's go back to the box method on this one. So A is 6, B is negative 13, and C is negative 5. AC, we got 6 times negative 5, so that's negative 30. So we need two numbers that multiply to get negative 30 and add to get negative 13. So you have negative 30 times 1, negative 15 times 2. These two will add together to get negative 13. So there's our two numbers. All right, start the box. We got 6x squared in the upper left. We got negative 5 in the lower right. And then we got these two numbers for the other two boxes, negative 15x and 2x. All right, there's our answer boxes. And now we'll factor in 4 directions. In this direction, greatest common factor of 50 and 5 is 5. Here, the greatest common factor of 6 and 2 is 2, and we have an x. This way, greatest common factor of 6 and 15 is 3, and we get an x there. And greatest common factor of 2 and 5 is 1, so we get a 1 there. All right, now let's deal with the negatives. We got positive, 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 negative, turns this one negative. So our factored form is 3x plus 1 times 2x minus 5. All right, our last topic today is multivariate polynomials. So these are polynomials with more than one variable. Now the same process works in factoring these. We just need to account for the other variable. So first example, x squared minus 5xy plus 6y squared. Okay, so we're back to an a equals 1 type of trinomial here. So we can go back to the other method we learned last time. So here, instead of just looking for factors of a single number, now we've got 6y squared here. But it's going to work exactly the same way. We got two numbers that multiply, or two expressions that multiply to get 6y squared. And each of them should have a single y in it to get this to work out. And then we want those two numbers to add to get negative 5. So we could have like a negative y and negative 6y. If we multiply these two together, we get positive 6y squared. We could also have negative 2y and negative 3y. Multiply these together, we get positive 6y squared. And if we add these together, we get negative 5y. Just ignore the x. So those are the two we want. So these are the two things we're going to stick in the binomials. So whereas before, when we didn't have the y's, when we just had x squared minus 5x minus 6, we ended up with x minus 2, x minus 3. Well, we've got a very similar thing this time. We're just going to put a y in there, in each one of these. So we get x minus 2y and x minus 3y. And there's the fully factored form of that. Now let's FOIL just to check. X times x is x squared. X times negative 3y is negative 3xy. Negative 2y times x is negative 2xy. And negative 2y times negative 3y is positive 6y squared. Combined like terms, we get x squared minus 5xy plus 6y squared. So the only difference in factoring one of the regular ones that we saw before looked like this. The difference between that and this one is the second term in each binomial is going to have a y in it. Your turn, number 6. So for 6, we want two numbers to multiply to get negative 8y squared and add to get plus 2y. So in this case, we're going to have 4y on the left, negative 2y on the right. These two add together to get positive 2. So our factored form would be x plus 4y and x minus 2y. Your turn, number 7. All right, now we want two expressions that multiply to get negative 21y squared and add to get positive 4y. And those would be negative 4y and 7y. So we get x plus 7y, and whoops, not 4, 3. There we go. Negative 3y and 7y. That's better. And when we FOIL this, we get that. Okay, your turn, number 8. All right, now we want two expressions that multiply to get negative 10y squared and add to get negative 3y. So that's going to be negative 5y and 2y. These will add together to get negative 3y. And that gives us x minus 5y times x plus 2y. So these a not equal 1 trinomials, they take a bit of practice to get used to, but I recommend trying both methods until you find one you feel comfortable with, and then just stick with that one.